Welcome everyone to the postcast test discussion of Biweekly contest 112. Uh, I will explain all the four questions. I'll start with A. Okay. In the first question, we're given two strings S1 and S2, both of length 4, consisting of lowercase English letters, and we can do a swap operation if like the indexes differ by 2. Like we can swap I and I plus 2 to index. Uh, we can swap I and I plus 2 to index because that j minus I equal to 2. That's all. Okay. We have to check if after swapping we can make both strings equal. Okay. What is it? A B C D, and C D A B are given. Okay. So if after looking at the test cases, if we say see we can swap this C and A. What will happen is C B A D. Okay. Then we can swap this B and D. Then the string will look like C D A B, and both strings are equal now. Okay, in two operations. Okay, we don't have to minimize any operations or do anything. Like we have to just check if both are strings are equal. So one thing to notice is that what happens, we can swap I and I plus 2 to index. So from this, if we have a string A B C D E F G, okay, you can observe that I can swap A and C and E and Z, because they are both two indexes differ. Their indexes differ by 2. Okay, now I can reorder these indexes in any way. Like I can bring C here, C in the last index, or C in the beginning by swapping, or E in the last, or E in the beginning by swapping. Like however we want. But we cannot bring this C to this index, because I cannot swap I10 I plus 2 index. So the thing to notice is this: if the indexes are of same parity, like if the indexes are odd or even, we can swap them. Like we can rearrange them anyhow we are, if we like as we like. Like I can swap this. I can bring this C here, or I can bring this A here, or I can bring this C here. I can bring this B here. That means I can, if indexes are multiple of 2, I can swap, I can rearrange them anyhow I like, or if the indexes are not multiple of 2, I can rearrange them anyhow I like. So that is the thing. Like what we will do is uh, uh, we will find the string, the characters in the uh, odd indexes of the first string and the odd indexes of the second string, and we'll check if they are anagrams. And again, we'll check the even indexes of the first string and even indexes of the second string, and we'll check if they are anagrams by sorting them. Like if after sorting them they are equal, they are anagrams. Okay, so I guess we can go for the code. In the code, the strings are for length 4. What I have done is I am taken a vector, and I have picked all the characters of in indexes, like even indexes, then sorted both factors. If they are not equal, like if the elements in the like even positions are not equal, then it will always be false. We cannot like make them equal. Like if I have A C B A C D and A C B. This A and A D N AB are AB will be always different because there is different character, or this one. This will be always different because I cannot bring this C here. This A and D and C will be always different. So I've sorted them. If they are not equal, I'll just return false. Then I have cleared the two vectors. Again, I am taking the odd inputs, like odd characters, and sorting them again and checking if they are equal. If they are equal, it will return 1, or if they are not equal, it will return false. Now for the second question. Now for the second question, the first and the second question is same. You can check this. See, this is the minus is even. Now we are given like more flexibility. So, but I still cannot swap the indexes, like odd indexes, odd and even indexes. I cannot swap I and I plus 1 because that will be not even. So I cannot like touch I cannot rearrange a element from a even index to odd index. So the code will be the same only. Just previously we have taken from only length 4. Now we'll take for length n and check the if for the even indexes the strings are anagrams, and for the odd indexes the strings are anagrams. And that is all for the second question also. Now I'll go for the third question. Okay. In the third question, we have to find the maximum sum of almost unique subarray. And for understanding what is almost unique subarray, a subarray is almost unique if it contains at least m pairwise distinct elements. Like if we see here 2, 6, 7, 3, there are 4 distinct elements. And if we see here, there are 3 distinct elements because say 7 and 7 is same. So we can see that there are 3 distinct elements. Now we have to find in the subarray of size k, we have to find the maximum sum. So for this question, we can notice that we can notice that like we have to do this in O of n. So this question we have to just find like the sum and the unique elements in a k-size subarray, k-size window. Like if we can find the somehow find the sum and check if the unique elements in the k-size subarray is greater than equal to k, then we can find if this sum is maximum or not. Like if we check here 2, 6, 7, 3, there are 4 different elements. The sum is 8 something 18. The sum is 18, and we can take this subarray, we can take this subarray, like all the 4 size subarray here is pairwise this thing and have like at least 3 different elements. But in this question, let's see, there are 5. Not discussion. Let's see discussion. We have to find the subarray of 3 size, and there should be 3 distinct elements. Let's check this subarray. Like this subarray is of 3 length, and how many distinct elements it has? 2. Okay, we cannot cannot take this subarray. Now let's check for this subarray. It also has a distinct character of number 2, and we cannot take this. It also has a distinct 2 distinct characters only. We cannot take this, and we cannot take any of these subarrays. Now, if somehow we can find all the k-size subarrays, and there are like how many different distinct elements are there, we can find the answer. Okay, now what we can do is we can apply a sliding window and check like if there are more than m distinct elements in the array, in the that subarray. Like if I check for 5992, there are 3 different elements. Now I will ignore this 5. I'll just delete this 5. I'll check for this window. Like there are also 3 distinct elements. We can take this sum also. I'll just delete this 9 and I'll again check for this subarray if there are 4 different elements. We can take this also. I'll do this 9 also now. I'll just check for this subarray. Sorry, I have to take care of 3 subarray. I will check for this subarray. There are also 3 different elements. Then I'll check for this subarray. There are 3 different elements. I'll just now if I delete this 4, the subarray size will be less than 3 only. Less than 3. I cannot take this subarray. So what I'll do is I'll just iterate for the k length subarray. I'll just delete for previous element. Then I'll take the next element. I'll just delete the previous element and I'll just take the next element. I'll take the previous index and I'll take this indexes. Okay, now let's go for the implementation part. I have taken a like unordered map to check the count of the elements in the array. For the first window, like there should be at least 3 elements in this window. Like I can take 5999, but I cannot take only 5. I cannot take 59. So for the first loop, I am iterating for k elements and taking counts of like how frequencies of every elements and sum of the k size subarray. If this like count dot size gives the number of distinct elements in that map currently in the map, if that size is greater than equal to m, I can take that subarray, and the answer will be that sum can be the answer. Now I've initialized is j equal to 0. This will be the pointer that deleting pointer, like which element I have to delete. It will introduce to that. Like for this subarray, I don't have to delete anything. If I go to this subarray, I have to delete j equal to 0, means 0th index. For this subarray, for this, I have to delete j equal to 1. For that, I have to initialize I and I equal to k, like I equal to k because I have ended k here, k in k minus 1. I equal to k. I have deleted the previous element from the map, and I also decrease the sum by that element. If like frequency of that number becomes 0, I have to erase that number from the map because it will like hinder in the size of the map, and because it is not included in the map anymore, I have to delete that element. Then again, I have taken the current element, like I have just where my slide window is now. Then if the distinct number of elements in the map is currently greater than equal to m, that sum can be answered, and I have to take that include that sum in the answer. Then overall, I'm taking the maximum of all the sums possible, and that will be answer final answer. Don't forget to take long because the answer will be always long. It can exceed. Okay. Now let's go for the fourth question. Okay. Now in the fourth question, we have to count k subsequences of a string with maximum beauty. Okay. Now, what is a k subsequence? K subsequence is a subsequence of string having the length k, and all of its characters are unique. So, for the first thing is like I have to take a subsequence of this from this string, like the like if I have a string like A, B, C, D, E, something. I have to take a subsequence of length k with all unique characters. Like I have to take A, B, B, C, D only. I cannot take A, B, C, D, D, or I cannot take A, B, C, A, A. I have to take all distinct characters of length k. Now we can observe that. For the first thing, we can observe that there cannot be more than 26 characters because we are using small letter alphabets. So if k is greater than or equal to 26, the answer is not possible because we cannot take all unique characters. Then let's go for the next type. Let's go for the next part of the statement. We are given a function that f of c denotes the number of characters of c that occurs in s. If you check in this string, f of a means like the number of times a occurred in that string. Like a occurred for once in the string, b occurred for thrice in the string, d occurred for twice in the string, not for this k-length subsequence, but whole string. In the k-length subsequence, we have to take unique elements. Then what we have to do is we have to find a maximum beauty. And what is the beauty? Beauty of a like subsequence is the sum of these frequencies of all the characters in the whole string. Like if I take a b from this string, the beauty will be 1 plus 3. If I take a b d, the beauty will be 1 plus 3 plus 2, because the frequencies are like 1, 3, and 2. That is all the statement part. Like we have to we have to return the answer modulo 10 to the power 9 plus 7. Okay. Now what we can observe from the question. First thing I have told that k cannot be greater than equal to 26. So the beauty will be 0 because we cannot find 27 different characters. So the first thing I have done is like if k is greater than equal to, return 0, because it is not possible. Now one thing to notice that k becomes lower. Oh, okay, lower, like smaller. Like what first intuition I got is like to do some DP or stuff. But then I realized even if k becomes smaller, I have to take like this size of DP and into k, not into k, into sum of k, sum of k. So this is greater than, I guess, 10 to the power 8 or 10 to, it will become 10 to the power 10 around. So we cannot use DP here. First thing to observe. Now let's see some maths, if we can like calculate, do some maths and something like that. Okay. The first thing will be to find a maximum beauty of the subarray. Like if we take a subarray, how can we find a maximum beauty? The maximum beauty, like if we say this thing, the maximum beauty, how much will be the maximum beauty? How can we find it? Here are two C characters, one B character, and one A character. Maximum beauty will be only if I take the like characters that occurred like maximum numbers times. Like if here C occurred 2 times, I have to always take C, because C occurred maximum number of times. Because if I do not take C, like it will decrease only. I have to always take C, 2 or C, and I can take any one from B on A. If I take A, this will become 3. If I take B, this will again become 3. Otherwise, it is not possible. Sorry, otherwise it is not possible. Okay. B plus C, B plus C, B plus C, B plus C. Okay, let's try to calculate from this, like this string, and the answer from this string. How many times we can like take choose a C from this 2 C's? Like we can take 2 times, like I can take this C or this C, like 2 times. That is the frequency of the character. I can take this C 2 times. Here also I can take this B 2 times only. The frequency of the character 2. And I can choose any one of A and B, any one of A and B. The answer will be 1, 2 into 1. If I say choose A, or 2 into 1, if I choose B, the answer will be 4. Yeah, you can also check that answer is 4. 3, 3, 3, 3. Now go for the second string also, if we will try to calculate the answer. The frequencies are like, if we will calculate the frequencies of the all numbers, B occur 2 times. Okay, wait 1 second. Okay. Okay. B occurred B occurred twice. B occurred twice. C occurred once. D occurred once. A occurred once. Now we can take a subarray of length 4. Okay, length 4. We have to always take this B because this has a maximum frequency. Okay, D. If I choose D, the answer will be multiplied by 2 only because there I can choose this B or this B, any one of these B. The answer will be multiplied by 2. Now I have to take 3 ones, like from this there are 3 ones, like 3 ones. This there are C occurred once, D occurred once, one occurred once. I have to make the sum equal to 4, like the length of the subarray equal to 4. I can this C, I have to take this C, I have to take this D, I have to take this A. Then only the answer will be of length 4, because 2 occurred twice, but we cannot take B occurred twice, we cannot take B again and again. So answer will be 2 into 1 into 1 into 1 equal to 2. That is the simple approach, but because we just have to check the maximum occurrence, like which element characters occurred maximum times, we have to always take that one. Now let's check for something like different. Let's check for k equal to 3 for this same string. B occurred twice, k equal to 3. I'm taking k equal to 3. B occurred twice. I always have to take B. The answer will be multiplied by 2 because I can take this B or this B. Answer will be multiplied by 2. Then I can choose any two from these three characters. I can choose CD, CD. I can choose BCD or BDDA, BCA or BDA or BDA. Okay. Okay. I can choose like the any two like two. There will be like different pairs. How many pairs will be? 6 pairs will be there. I have to check 3 pairs will be there. I'll take any two. I have to take any 2 characters from these 3 characters. Okay. How many will be there? Like I'm given 3 characters. I have to take any 2 from this. This will be 3C2, 3 into 2, the other 2 equal to 3. You can see there will be CD. I have to take only 2 characters because this string length should be 3 subsequent length. BCD, the absence on the subsequent as well. BCD, it can be BCA or it can be BDA. This will always be converted to 3C2. So what we can do for the answer part, how we will calculate the answer now. So for the answer, we'll go like we'll find the frequencies of all the characters, all the 26 characters. We always have to take the maximum from the maximum top, like top maximum k different like characters whose frequencies are maximum. Maximum k characters whose frequencies are maximum. Now let's see if frequency of A is 5, B is 4, C is 3, and this length is k equal to 3. I always have to take B, A, the like I can choose one from 5S. I can choose one B from 4S. I can choose 1C from 3S. The answer will be 5 into 4 into 3. Now see if like say I will add one character, more character, D equal to 3. Now you can see that I can choose any one from this to C or this, like anyone from this to C and this. If I choose C, the answer will be multiplied by 3. If I choose D, the answer will be again multiplied by 3. But it got added. The answer will be like 2, like from these two characters, I have to choose one, 2C1 into like occurrence of these characters. That is 3. That is a simple part. Like I have to check, like I have to take the